This is the second part of Chapter 1 in the Green Book of the test review. We got cut off when I was just a couple slides away from being finished. Let's go ahead and finish up here. So our next thing that we're going to be working on is approximating irrational numbers. So these are the ones that, once again, do not work out perfect. Okay? So I'm going to start with pi. And we talked about pi a little bit earlier. Hopefully you just know this number, and the approximate value of pi is 3.14. Like I said before earlier in this installment, it will go on forever. Some of my students have known up to 100 digits of pi, 3.141592, and we can go on and on and on. But if you know 3.14, you're getting a pretty good approximation, and that's why that's what most calculators, what classroom teachers will ask you to use. When you put it in the calculator, it will give you the exact. Square root of 2. Okay, now we're having to approximate square roots. So let's jump to c first, and that will help us. So c actually is not an irrational number because there is a square root of 4. And the square root of 4 we know is 2. And because we know that when it comes out to be a whole number like 2, that is actually rational. I put that one up there because that helps us. So when I want to approximate a square root, so I have the square root of 2, I got to find which perfect square is just below it and which perfect square is just above it. So the perfect square below it is the square root of 1. Then I'm dealing with the square root of 2. And the square root of 4 is the next perfect square above it. So the square root of 1 is less than 2. And the square root of 2 is less than the square root of 4. Well, the square root of 1 is 1. So we can say 1 is less than the square root of 2, which is less than 2 because the square root of 4 is 2. So I know that the square root of 2 falls somewhere between 1 and 2. So my first digit in this in solving is 1. The next thing I'd like to do is find out the distance between these digits. So from the square root of 1 to the square root of 2, I have one number. But if I want to go from the square root of 1 all the way to the square root of 4, that is 3 digits. So I can kind of say it's 1 1/3. It never works out perfect. This is not an exact science. This is to get an approximation. And so what I'm looking at is the proportion of distance from the square root of 1 to the square root of 4. And where does the square root of 2 fall? Well, it's about 1/3 of the distance. So I can say it's about 1.33, because 1/3 is a decimal, is 0.33. And it usually falls a little bit higher. So on this approximation, I'm going to say something like 1.35. Okay, that should get me close enough. If you're within a tenth, you're doing great. So this was just a little approximation. It's probably actually a little higher than 1.35, probably 1.37. Let's try the same thing with the square root of 8. Perfect square below the square root of 8 would be the square root of 4. Then I have the square root of 8. Then I have the square root of 17. Oh, sorry. I don't know why I put that. I'm sorry. I was looking at the next question. And then I have the square root of 9. Well, if I look at this, 4 is 2. 9 is 3. So I know the number begins with a 2 because it will fall between 2 and 3. The distance between 4 and 8 is 4. And the distance between 4 and 9 is 5. So I'm going to guess about 2 4/5, which, if I know 4/5 is a speed number, is 2.8. 0.8, we always said we give it a couple of hundredths above it, so I'm going to call it 2.82. And we'll be pretty darn close. Let's look at our last one, the square root of 17. My perfect square below 17 is the square root of 16. We're at the square root of 17, and the next one is the square root of 25. So 16 is 4. 25 is 5, so it is between 4 and 5, so my first number should be a 4. The distance between 16 and 17 is 1, and the distance from 16 to 25 is 9. So 4 1/9, if I know 1/9 is a decimal, that would be 4.11111. It's a 1 repeating. I'll always round this up a little bit like I continue to say, so I'll call it 4.13, and we're good to go. So what we're going to do with approximating square roots, find the perfect square just below it, the perfect square just above it, find the proportion of distance between the two, and you will come out pretty darn close. I think you'll always come out to within a tenth. Okay, ordering numbers on a number line. Well, let's look at our different numbers that we have. I have pi. I know that's 3.14. Square root of 5, I'm going to have to do what I just did. Let's take the square root of 5. So I'm going to take the square root of 4, square root of 5, square root of 9. Well, that's a 2 and that's a 3, so I know this is 2. It's 1 away, and that's 5 away. So about 2.2, and we'll round it up to 2.22. Okay, my next thing, the square root of 2. We did that on our last one, and we came out to about 1.37 because we said the square root of 1 and the square root of 4. And then we have a 2.5. Well, since all the rest are at 2 decimal points, why don't we call 2.5 2.50 just to look at them a little bit easier. My next one, negative 3. Since everything else is out to 2 decimals, we can put 2 decimals. It doesn't really make a difference. My next number, negative 3/4. If I know my speed numbers, 3/4 is 0.75. So negative 0.75. Negative 1/3. Once again, you know your speed numbers, negative 0.33. If you don't, then you would have to divide the 4 into the 3 for 3/4. If you didn't for 1/3, you'd have to divide the 3 into the 1. My last one is negative in the square root of 10. Well, let's look at the square root of 9. Square root of 10, square root of 16. That's a 3. That's a 4, so I know my number has to be a 3. 9 to 10 is 1. 9 to 16 is 7. That's 3.4. I'm messing up here. 3.14. And I'm going to bump it up a little like we always say, so negative 3.16. I know I'm going a little fast on that. You can slow it down, see step by step where we're getting these numbers. Now we've got to put them on a number line. My biggest negative is my smallest number. So I'm going to look at all these, find my biggest negative. Well, that would be right here. Negative 3.16, which is negative square roots of 10. So I'll go negative square roots of 10. That is my smallest number. My next smallest number, well, that'd be negative 3. So let's put in negative 3. My next biggest negative, negative 0.75, which is this one. So negative 3/4. And out of my negatives, the only one left, my smallest one, negative 0.33, which is negative 1/3. Now we find the smallest positive number, which is 1.37, which also corresponds with the square root of 2. Oops, my board's messed up for 1 second. Let me get it back. Square root of 2. Okay, let's look at the next thing. 2.22 is smaller than 2.50, so the square root of 5 would be my next smallest number. As we look up, 2.5, and finally pi. So there we ordered our numbers. You can put that on a number line also, and we just need to make sure they all correspond with their decimal counterparts. Okay, significant digits. There's 4 basic rules we need to know. All non-zero digits are significant. So if they have a full number, they are significant. So 533 has 3 non-zeros. 6.223, well, all those are non-zero, so they're all significant. There's 4 numbers. 1.2, there's 2 non-zeros, so I have 2 significance. My next significant digit is zeros in between non-zero digits are significant. So look, I have a 0 here, but I have non-zeros on either side, so there's 4 total digits. A 0 in between there, so I have 3. Here I have a ton of zeros, but then I have a 4 at the end. So every one of those is significant to give me 9 significant digits. Trailing zeros in a decimal are significant, meaning if they're at the end, trailing, they're at the end, but they're with a decimal point. Yes, they are significant. So that is an important factor. It is if there is a decimal. If there's not, then those trailing zeros are not significant. But if there is a decimal, they are significant. So here I have a 2, a decimal point, and a 0. So I have 2 significance. Here I have a decimal and 2 at the end, so I count everything. 4, 1, 3, 2, 0, 0. So I get 6. The last one, 2.3, has 3. Zeros on the left of the first non-zero is not significant. Not. So until you hit your first non-zero number, they're all not significant. So 0.2, that only has 1. 0.003 still only has 1. 0.0203. Well, the first 2 zeros aren't, but that middle in between the 2 and the 3 is, and that's why we have 3. Here at the end, 0.02300. Well, that has 4 because these 2 are at the end after a 0. They're a trailing. So the one example I do want to give, though, is if I have 32000, there is no decimal point with this one, so it only has 2, because those trailing zeros are not with a decimal point. Rounding to significant digits. So this one wants you to give it to 3 digits. So we can only have 3 that matter. So that means to write here. And I would need to round the 4 to keep it the same or up. And the 5 says that I will round it up. So I'll have 2, 3, 5, 0, 0, 0. So I still have the same basic number, 234,567. But at 3 digits, we call that 235,000, and we're done. My next one only wants 3 digits. So that's my first, second, third. So I got to see if this 0 rounds it up or down. Well, obviously a 0 is not rounding anything up. So my answer now is 0.0034. I have 3 significant digits now. Last one says it wants 4 significant digits. So 1, 2, 3, 4. Put it here. So I got to find out if that 7 is being rounded up or staying the same. Well, a 3 will not round it up. It will stay the same. So I have 0.2037 at 4 significant digits. Calculating area to significant digit. It says the area of a triangle with height of 2.23 and a base of 11.14 to 3 digits. Well, if we know I have a triangle, its height, it says, is 2.23. Its base is 11.14. The formula for the area of a triangle is 1/2 base height. Now all you have to do is plug things in. I'm going to go 1/2 times 2.23 times 11.14. Let's go ahead and do our math here. So 2.23, we'll go ahead and change colors. Come on over here and take a look. And I have 11.14 times 2.23. 3 times 4 is 12. Put our 1. 3 times 1 plus 1, 4. 3 times 1, 3. 3 times 1, 3. When I'm on my second one, I have a 0 that's placed here. 2 times 4 is 8. 2 times 1 is 2. 2 times 1 is 2. 2 times 1 is 2. My last one, I put 2 zeros now. 2 times 4 is 8. 2 times 1 is 2. 2 times 1 is 2. And 2 times 1 is 2. Let's go ahead and do our addition. 2. 2. Put a 1 up here. 4, 6, 14. Put a 1. 4, 6, 8, 4, 2. Now to figure out where to put my decimal point, I'm going to go ahead and look at how many I already had. I had 2 here and 2 here, so I have 4 decimal points. So 1, 2, 3, 4. At 24.8422. I don't do anything with significant digits yet. I'm not having to deal with that yet because I still have one more part. Because now it says 1/2 times 24.8422. That would mean I'm going to divide that by 2. Because multiplying 1/2 is the same as dividing by 2. Okay, so I'm going to divide this by 2. 24.8422 divided by 2. Well, that's 1. That's 2. Put my decimal point here. That's 4. That's 2. That's 1. That's 1. So my final answer here is 12.4211. But it doesn't ask me to go all the way out. It asks me to go to 3 significant digits. So let's go ahead and draw a little line here at 3. The 2 is going to decide if I round that 4 up or not. And 2 is not going to round up. So I'll have 12.4 as my final answer. Thank you very much. Thank you for tuning in. Hope this was helpful.